Merci beaucoup pour l'invitation.
Thank you very much for inviting me. I hope you can hear me loud and clear. I will be speaking in French because this is a question of protocol in international organizations. So for those of you who do not understand French, I encourage you to use the headsets and you will see my slides in English, which should make it easier for you to follow my presentation. So I was requested to give you an overview of the role of software in the French National Plan for Open Science. So a few words about open science and our national plan. I'm very proud and very pleased to see that UNESCO has made this issue international and global, because often when you say global, you only mean Europe and North America, but this is a truly global strategy for open science, and we want to bring our contribution to this. But it's always important to remember and recall why we are in favor of open science. Well, it's an issue of principle. This is public money that should benefit the public at large, and we should ensure that the beneficiaries are those who paid into the science, so with public money. Then there's a scientific objective to ensure better quality research. I'll come back to that. And then there's a societal reason. Open science is more accessible to society at large, and in these times of pandemic, we all understand why that's important. So if we delve into the details, open science leads to greater impact with more readers, more diverse readers of scientific work, and all research shows that the more you disseminate science outside of the small community of scientists, the greater impact. Then it promotes better budget and economic efficiency, and means that smaller organizations who have an higher transaction costs. So there are over 12,000 publishers around the world for scientific research. And so if a small municipality, for example, wants to access all this information, they would have to subscribe to the 12,000 ones, which is unfeasible. Then there's the issue of reproducibility. So with open applications, data, protocols, and software that are all open, it makes it easier to reproduce. And so if it's not the only way to ensure that, it is nevertheless essential. Then there's heuristics. You can choose between a closed science where you duplicate results and results and research are redundant. 50% of clinical trials in oncology, for example, in Europe never lead to a publication. It's important to keep that figure in mind. 50% of clinical trials on cancer cases do not lead to scientific publications. And that's an illustration of redundant efforts. The idea of open science is that you create cumulative science. And so it's a way of coming back to the cumulative science project that dates back to the Middle Ages. And then there's the issue of ethics, integrity, and transparency. This is an ever-growing concern in our planet, and open science is one of the answers to those questions. And the number one beneficiary of open science is the researcher, him or herself. I think that we all remember the software that we created 10 or 20 years ago. And if we were in an ecosystem at the time where this was preserved and conserved, well, we would still have that today. And I know that I have students who are retrofitting and trying to access software we created 20 years ago, and it's nearly impossible. So open science is a way of making all this professional and involving third parties. So that was a very lengthy introduction. A bit of history. The Minister for Higher Education, Research and Innovation in France launched on July 4th, 2018, the first national plan for open science. And she also created the Open Science Committee, a governance structure with various levels of coordination, including a number of experts, including Roberto Di Cosmo and many organizations such as INRIA. And we started to measure impact. So this is the Open Science Monitor. We started at 41% of open access. 2 years later, 56%. And in February 2022, we'll have the outcome of the 2021 National Plan. We've also recruited a National Chief Research Data Software and Algorithm Officer. The idea is to have individuals who are there to develop and implement policies, and it's Isabelle Blanc who was recruited to play this crucial role, and I hope other countries will create a similar position, which is essential. There is chief data officers in every company today. It's essential that ministries have their own CDOs, and France has decided to extend that to software and algorithm. And we hope that we won't be the only ones to do this, and we hope there'll be CDOs that are also in charge of software and algorithm in the future, and dealing with them not as data, but as software and algorithms, and that are different artifacts.
We launched the second plan for open science this summer. It was announced by the Minister for Higher Education, Research and Innovation. It triples the budget for open science. And this is now the purpose of my presentation, creates a whole chapter on software and code. The first plan was for traditional items, transformation code and publishers. Now we have a dedicated chapter on source code, and this was something that was missing. It was a gap in open science policies in general. And whereas it's a first-class research object, just as publications are, as methodologies, as protocols and data are. So the plan is determined to be part of a Europe-wide, a European policy plan, and France will be presiding the EU from January to July. So there will be various open science initiatives during the French presidency. And with this plan, there's a very strong anchoring in the disciplines. We had a first generic plan that seemed to work for everybody. Now we're going into greater detail. And what I said, for instance, about clinical trials raises the issue of regulation, observation, and support measures when you're talking about something like code. I can't go into much detail in terms of the various measures, but I will share my slide presentation, and I will simply focus now on software. So the first chapter is on opening publications with a focus on diversity, what we're calling the diamond model, which is an open access where neither author nor reader is charged, and which encourage multilingualism. And I'm very happy to be able to emphasize this point here at UNESCO, because if we really want to go all the way with this approach, we can't simply try to save money on subscribers. We have to be concerned only with impact and usage. If we publish 95% of our health-related publications in English, it means that we're excluding all of our citizens from those results. And 95% of our publications are in French. Then we're also giving up reaching a wider audience in a non-French speaking world. So we're not asking researchers to change the language in which they publish, but we're offering them translation opportunities for part of their publications. Of course, this will be based both on human translators and AI. AI, of course, where we've had significant progress in this area. Now, we will be sharing a national data platform for sharing data. It will become operational at the end of the first semester 2022. Now, let me talk about source code and software. So first time we have a strong public policy which is intended to recognize and support the dissemination of software in an open source license that is of public provenance, to highlight the production of source code, both in careers and higher education. And lastly, define and promote an open source software policy, knowing that this is a major pillar of replicability, and knowing that open source licenses have to be given preference. There may be exceptions, but the standard has to be dissemination in open license format. I don't want to go into much detail. I would just like to highlight a few points, because we have an administrator for the data at national level. We're trying to make sure that this kind of role exists within the institutions, so that in institutions there is a contact point who can develop the public policy. So this is a very important measure. And here again, the idea is to have persons who are responsible for this, so it doesn't just remain abstract. We will create an open science prize that will be awarded in early February at the Academy of Sciences. This should contribute to a broader ambition, which is to recognize the contribution to software and from open science, because once again, first-class research object. There's the whole continuum, and software just part of the continuum. It should be the first item, nor should it be the last item on the continuum. And part of the Committee for Open Science that I mentioned, and the national governments that we have set up, we decided to create a collège for software and open source code in order to coordinate our work in a collegial fashion on a topic which is technical, like all open science subject is, and on which general announcements or statements are not sufficient. Lastly, we want to articulate, to coordinate the various items. These are not tunnels of publication, code, but all of this has to be interconnected. And for this, publications are very important. And here we can act so that the citation, the interconnection between the various items are no longer an exception, but be standard. So where just one person uses a format or a standard, we need to know what the best practices are and to share them. And I would like to emphasize the fact that France is supporting more than 100 research infrastructures. Here's our roadmap for 2018. Okay, but we're working now on the 2022 roadmap. We analyze for these 100 research infrastructures of their open science policies. What we saw is that it's very diverse in all the disciplines. It goes from aeronautics to ships, their submarines, their particle accelerators, and their purely digital infrastructures. And we saw that many infrastructures had, for a long time now, had open code. It was just a tradition in software since the 80s. And I think that maybe software heritage could be part of the next roadmap for 2022 for national research infrastructures, just like other infrastructures. In France, we've already done a lot of work. There's a very nice project. I would like to urge you to look at how they finance this. It's financed by the EU. This one you know a lot. ISU Portable, maybe you don't know it well. It produces tools for universities, but they're all open, and of course, software heritage, which is our gold nugget. But there's a lot more to be done, and we have to do it internationally with strong coordination in a very coordinated fashion. I just wanted to give you a few examples to convince you that this is not just public announcements or grandstanding, that people are really working on this, and they're just waiting to be recognized. And the fourth part of our national plan is about transforming the landscape in the practice of research in France, so that open science will become the default principle, default practice. to this end, we'll be doing several things. We will look to value open science and the diversity of scientific production. And this is very important. We have to consider that producing a reference data set is equivalent to a reference publication. That's very important. We're working at national level and at EU level to change the valuation or assessment system, which is a bit monochromatic and unchanging. I'd like to invite you to Paris. I know you're already in Paris, but to come to the Paris Open Science European Conference. Is organized by France under the France's presidency of the EU. And here we'll be talking about health, diamond publishing, evaluation reference, and source code. And we will award the first prize for open science. Thank you.